Hello and welcome. In this video, we will explore an essential concept in Python programming. If you have ever needed to repeat an action multiple times without manually writing each step, then loops are your best friend. Loops help us automate repetitive tasks, making our code more efficient and easier to manage. Instead of writing the same instruction over and over again, we can use a loop to repeat it for us. A for loop in Python is a powerful tool that allows us to go through each item in a sequence, such as a list, a string, or even a range of numbers. It picks one item at a time and performs a specific action on it before moving to the next item. Think of a for loop like a conveyor belt in a factory. Imagine a belt carrying different products, such as apples, bananas, and cherries. At each station, a worker picks up the next item, processes it, and then moves on to the next one. The loop continues until all items on the belt have been processed. In Python, the conveyor belt is our sequence, the worker is the for loop, and the processing step is whatever action we want to perform on each item. For loops are used everywhere in programming, from processing lists of student names to analyzing data in spreadsheets and even controlling game mechanics. Whether you are working with text, numbers, or more complex data, the for loop helps you handle repetitive tasks with ease. This was just a quick introduction to for loops. Next, we will break down the syntax in detail and show you how to use for loops with different data types. A for loop follows a simple structure. We start with the keyword for, followed by a temporary variable that holds each item from the sequence, then the keyword in, and finally the sequence we want to loop through. The line ends with a colon, and the next indented block contains the actions we want to perform on each item. Let's look at a basic example. Suppose we want to print each letter in the word hello. We can use the following for loop. This loop takes each letter from the word hello, one at a time, and prints it as you can see. In this example, letter is a temporary variable. It holds one character from the word hello during each cycle of the loop. On the first iteration, letter is H. On the second, it is E, then L, and so on, until the loop reaches the end of the word. This temporary variable can have any name you choose, but it should describe the data it holds to make your code easy to read. For example, if you are looping through a list of students, you can name the variable student instead of something generic like X. Python relies on indentation to define blocks of code. Everything inside the loop must be indented. If you forget to indent, Python will throw an error. For example, this will cause an error because the print statement is not indented. Always make sure that the code inside the loop is properly indented for it to work correctly. For loops work with many different types of data, not just strings. You can loop through lists, tuples, and even dictionaries. Here is an example using a list of student names. The same logic applies to looping through other sequences, making for loops a flexible and powerful tool. Now that we understand how for loops work with sequences like lists and strings, let's introduce a useful function called range. The range function helps us create a sequence of numbers and is commonly used when we need to repeat an action a certain number of times. Instead of manually creating a list of numbers, we can use range to generate them automatically. The range function in Python can be used in different ways. The simplest form is range with one argument, like this. Notice that the loop starts at 0 and goes up to, but does not include 5. By default, range starts at 0 and increases by 1 each time. If we want the loop to start at a different number, we can provide two arguments, a start value and a stop value. Here, the loop starts at 1 and stops before 6. The stop value is not included, which is an important rule to remember when using range. We can also control how much the number increases in each loop by adding a third argument. This is called the step value. The loop starts at 1, adds 2 each time, and stops before 10. If we use a negative step, we can count backwards. The loop starts at 10, subtracts 2 each time, and stops before reaching 0. The range function is extremely useful when we need to run a loop a specific number of times. For example, if we need to print a message 5 times, instead of writing 5 print statements, we can use a for loop with range. This prints hello world 5 times. The range function is a powerful tool that makes loops more flexible. It helps us work with numbers efficiently without manually creating lists. Now that we understand range, we can combine it with lists, tuples, and dictionaries to create even more useful loops. Looping through lists and tuples. A list is a collection of items that can be changed, while a tuples is similar but cannot be modified once created. For loops allow us to go through each item in a list or tuple one by one without needing to track their positions manually. Let's start with a simple example where we have a list of student names, and we want to print each name. Here, the for loop takes each name from the list and assigns it to the variable student, then prints it. The loop continues until all names in the list have been processed. A tuple works the same way as a list in a for loop, except that its values cannot be changed. Even though tuples are immutable, we can still iterate through them just like lists. Sometimes we need both the index of an item and its value. We can use the enumerate function to get both. The enumerate function automatically keeps track of the position of each item in the list. If we need to modify a list while looping through it, we should be careful. Changing a list inside a loop can sometimes cause unexpected results. Instead, we often use the range function along with the len function to access items by index. Using range and len together gives us full control over modifying a list while iterating. Looping through lists and tuples is useful in many real-world applications. Whether processing student records, handling inventory in a store, or analyzing data in spreadsheets, for loops make these tasks easy and efficient. Now that we know how to loop through lists and tuples, let's move on to another powerful Python data type, dictionaries.